This is Owen Wilson. This is my geometry explanation for NMBR 142 for the sun shadow experiment. Eratosthenes was a Greek astronomer that calculated the circumference of the Earth by measuring the length of a shadow cast by an obelisk when the sun was at its solar noon. Now, if the Earth was flat, the obelisk would cast a shadow of the same length, but Eratosthenes realized that the Earth is curved because the angle of the sun makes the shadow length different in different locations. Eratosthenes then thought that if he could measure the angle of the sun using the shadows in two places on Earth, then he could use that to work out how many degrees around the curve of the Earth the two locations were from each other. By knowing this information, the circumference of the Earth can then be predicted. To do this experiment, I used my location in Middleton, Brisbane, and also another student's location in Rockdale, Sydney, which were roughly north-south of each other. We also compared the measurements we had at solar noon. It was also required that we both used an object of 1 meter high so we could have accurate results. For my part, I used a 1 meter plastic pipe with a whiteboard, a marker to mark the shadow, a tape measure, a protractor, and also a spirit level app on my phone to make sure the pipe was standing at 90 degrees to the surface of the board. I then used a website to check when the solar noon was for my particular day. Then I marked the shadows 5 minutes before and after solar noon. After this was done, the measuring tape was used to measure the distance from the pole to the marks. I found that the measurements were all roughly around 78 centimeters. Next, I used a corner of some paper to mark the height of the pipe 10 centimeters and the length of the shadow 7.8 centimeters to keep the same ratio as the experiment. I drew the hypotenuse between the two marks to get the angle of inclination of the sun. I measured this with the protractor and found that it was 38 degrees. This wasn't the true angle though. There is a mathematical equation explained in my report as to what it really is. The student from Sydney did this process as well. Now, if both of these pole points on the Earth drew a line to the center of the Earth, there would be an angle formed by the two lines at the center. We know that this angle is known as theta. Another way to work this out is to take away the biggest solar noon degrees from the other. We also need to know the distance between the two locations. Once all of this information is known, we should be able to do exactly what Eratosthenes did to work out the circumference of the Earth. This is covered further in my report. These are my image references, and thank you for listening.